So what are mutually exclusive events? Two events are mutually exclusive if they cannot occur at the same time, and it is possible when they do not share any outcome. So here we have shown mutually exclusive events in Venn diagram. So they do not share any outcomes, so they are mutually exclusive. And here we are showing non-mutually exclusive events. They share some outcome. So just because they share some outcome, they can occur at the same time and they are not mutually exclusive events. We'll see it with one example. Let's say the sample space is 1, 2, 3, 4, 5, 6. One event is 1, 3, 5. One event B is getting outcome 2, 3, 4, 5. So are they mutually exclusive? So they have 3 and 5 common. So if we draw it in this Venn diagram, so the event A is 1, 3 and 5 and event B is 2, 3, 4 and 5. So the event this 3 and 5 are common outcomes and they are not mutually exclusive. So here probability of A intersection B is what? First, let's say what is A intersection B? A intersection B is 3 and 5 and probability of A intersection B is 2 out of 6 because we have two outcomes in A intersection B. So probability of A intersection B will be 2 out of 6, that is 1/3. Let's say one more example with the same sample space. 1, 2, 3, 4, 5, 6. Event A is, let's say 2, 3, 4, 5. Event B is 1 and 6. So they don't have any outcomes in common. So they are mutually exclusive. If we try to draw it, event A is 2, 3, 4, 5 and event B is 1 and 6 and they are mutually exclusive. Here A intersection B is empty. They do not have anything in common and probability of A intersection B is 0. Now we'll try to see the intersection and union probability. First, intersection probability. As we already saw, if A and B are mutually exclusive, then A intersection B is empty. And then the probability of A intersection B will be 0. But if A and B are not mutually exclusive, then A intersection B is not empty set. There will be some common elements and probability of A intersection B will be greater than 0. Now let's see union probability. So we know the union probability formula, right? Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Now, just to remind, why do we subtract A probability of A intersection B? Because if this is the Venn diagram, here we have A, here we have B. So when we are calculating the probability of A, we are calculating this part. When you are calculating the probability of B, then we are calculating this part. So this is the region we are calculating two times. When you are adding probability of A and probability of B, we are adding the probability of this region two times. So then we have to subtract it once. So this is the union probability formula, and this holds for not mutually exclusive events. But if A and B are mutually exclusive, then you have seen probability of A intersection B is 0, because A intersection B is an empty set. So in that case, if A and B are mutually exclusive, probability of A union B will be probability of A plus probability of B, because this part is 0. So here we have shown the probabilities in a nice way. So if for mutually exclusive events, probability of A intersection B is 0, probability of A union B is probability of A plus probability of B. For not mutually exclusive events, probability of A intersection B is greater than 0, probability of A union B is probability of A plus probability of B minus probability of A intersection B. Now let's see one example here. In a class of 40 students, 25 students like maths, 18 students like science, 10 students like both math and science. A with the event that is student likes math, B with the event that is student likes science. So first of all, are A and B mutually exclusive? Let's find out. Uh, First, let's draw a Venn diagram. So there are 40 students in total. 25 students like math, 18 students like science, and 10 students like both math and science. So they are not mutually exclusive because they have this area in common, right? So there are few students that both like math and science. So A is the event that a student likes math, and B is the event that a student likes science. So A intersection B is not empty set, and probability of A intersection B is greater than 0. It should be greater than 0. So they are not mutually exclusive. Next, you have to calculate this probability. First, a randomly chosen student likes math or science. Means we have to calculate the probability of A union B, because student likes math or science, right? So we know the union probability formula, that is P of A, probability of A union B is probability of A plus probability of B minus probability of A intersection B. Now probability of A is probability of students liking math. So there are 25 students out of 40 students like math. Now what is the probability of B? Probability that a student likes science. There are 18 students out of 40 students like science. Now what is the probability of A intersection B? There are 10 students like both math and science out of 40 students. So the probability of A intersection B is 10 out of 40. So this comes around 33 out of 40. So that is the probability of A intersection, A union B, means probability that a student likes both math and science. Next, see the probability of a student likes only math. Only likes math means we have to calculate the probability of this part, right? So because we are not considering this intersection part, we are just have to calculate the students that likes only maths. So that will be probability of A minus probability of A intersection B. That is probability of A is 25 out of 40 minus probability of A intersection B is 10 out of 40, that is 15 out of 40, that is 3 out of 8. Next is we have this one. A randomly chosen student likes only science, means we have to calculate the probability of this part. So that is the probability that the student likes only science but not maths. So that will be probability of B minus probability of A intersection B. So that is probability of B is 18 out of 40 because 18 students like science, minus probability of A intersection B is 10 out of 40, that is 8 out of 40, that is 1 out of 5. Next we will calculate the last part. This one, a randomly chosen student doesn't like math or science. So doesn't like math or science. So when we calculated the probability of A union B, we calculated this whole region, right? So the probability of students liking either math or science. Now we want to calculate the probability of student that doesn't like math or science anything, like it will not, the student will not like math or it will not like science. So means we have to calculate the probability of this outer region, and that we can calculate as 1 minus probability of A union B, right? So that will be 1 minus probability of A union B is 33 out of 40. So this is 7 out of 40.